So in this particular video, we will do the implementation of the breadth first traversal that we have already been covered in our previous part of the video, right? We have seen the logical understanding of how breadth first search will work, right? Apart from that, we have seen the time complexity aspect of the same. Pseudocode part, I am expecting is pretty much clear to everyone. And if it is clear, then I know that maximum students are already able to do the code work as well. But those who are facing some issue or is struggling about the same, it's the right time to analyze your mistake and do the rectification for the same. So what I will try to do here is that I'll try to maybe take the same graph that we have covered up in our last class, because we know the answer of that particular part as well. So let me write the driver code first. So here I will be having, let me try to first of all create a visited, which is a set. Okay, I'll create the set here. After that, I'm having a graph. I'll create it as a dictionary. So A is connected with, in the form of adjacency list I am storing. So here I am storing the graph in the form of adjacency list, right? So now A is stored with B followed by C followed by D. After that, the B is linked with, I would say, I think B was linked with E, right? So B is connected with E in the graph. After that, C is connected to, I would say, A, B, C, D. So C is also connected to E and F. C is connected to E followed by the F. After that, D is connected with again only F. So I am referring to this graph which we have created. A is connected to B, C, D. C is connected to E and F. D is connected to only F, right? After that, we will be having, I would say, E, which is connected to G, right? After that, we will be having F, which is again connected to G, right? After that, we will be having only G, which is connected to, I would say, nothing, right? So it is empty. Now what we will do, we will just try to the function calling here, right? We will just try to do the function calling here, where we will call the function, namely breadth first traversal, right? Inside that, I will mention the visited set that we have created, the graph that we have, and from what point I am starting, which is the node A, right? Now let's talk about the function definition here. So here, if you will observe, I will be having the breadth first traversal. So what I can do here, def breadth first traversal, and here inside that I can pass the node. Now here what I can do, simply, if you remember in the queue data structure module, we have studied that we can do the implementation of queue in Python by using two functions and by using two ways. Either you can just do the insertion at the left side by calling the append left function and popping it by normal function called pop, or you can do append and pop left. In both of the ways, you can do the implementation of the queue. So for doing the implementation of the queue, we need to import the DQ, right? So what I can do from collections, I would say, I can import DQ first of all. Now in this particular case, if you will observe, we can initialize the queue by calling this function, which is DQ here, right? So here we will be able to initialize the queue. Now in this method, what I will do, I will first of all add the node inside this visited set. After that, I will just try to add this inside the queue by saying append left, So here, in order to do the implementation of queue, right? So when I am saying queue, means I want to implement the FIFO kind of structure. And in order to implement the FIFO kind of structure, either I will call append left for appending and pop for deleting, or what I can do is that I can say append for appending and pop left for deleting from the left side. Any of the two ways we can use that, right? Now I will just try to add the element by calling this append left, and inside that I can add this data. Now what I can do, I need to apply the while loop until and unless my queue is not empty. This is what we have discussed in our last class. So what we can say, while this queue is not empty, do one thing for us. First of all, try to delete the element from the queue. So we will call this pop function. Then we can print this node, and I will just apply some spacing here. Once it is done, what I want to do here is that I'll just call the adjacent nodes present inside the graph of that corresponding node that we have. And after that, what we can say is that if this adjacent node that we are looking for is not present in the visited part, means it's not already visited. So what I will do is that I'll just do these two things again. Means I'll just make them visited, and I'll just keep on adding it inside the queue that I have. I believe this part is pretty much clear to everyone. This is what we have discussed, right? So if you will go for the pseudocode, if it is not visited, then only I am adding it inside the queue, and I'll just keep on repeating the same task. So let me try to first of all run this code. Oops, it means something infinite loop is going on. I need to just shut off this kernel. So let me shut down this. Okay. So here if I will observe, while the queue is not empty, we are deleting the data, we are printing that, and then we are saying that if the adjacent nodes I am calling, if it is not in visited, we are just keep on adding that node. That is not I want. I want to add the adjacent nodes here. Now let me restart the kernel and run everything. Still it is happening. Let me try to see this. No. Now we are getting the correct output, right? A, B, C, D, E, F, and G. So I hope that everyone is able to understand the mistake. We don't supposed to write the node, otherwise it will go to the infinite loop. Here, if adjacent nodes is not visited, we need to add that adjacent node inside that visited array, and then we need to append that inside the queue, right? So this is the overall idea behind how breadth first traversal will work. So here if you will see, we did the implementation of breadth first traversal, right? And we have seen that to do the implementation of this BFT or BFS, the required data structure that we supposed to use is queue, because here in a way we are applying a FIFO kind of architecture, right? I hope that whatsoever part we have discussed in case of how this breadth first traversal will work is pretty much clear to everyone. Now let me ask you one question. What is the, I would say, beautiful application of this BFS or breadth first traversal? It is basically helpful to see that whether the graph is connected or not. Whether the graph is connected or not. How? If it is not connected, obviously you will be able to get some breakpoint. Try to do one thing today at your home. Take some disconnected graph and try to see a BFT or I would say DFT traversal of the same. Are you able to get an idea that whether the graph is connected or not by doing these kind of traversals? Do let me know for sure. But this is the overall intuition and the idea behind the same. Apart from that, there are a lot of applications of these traversal algorithms. I want you all to explore them first, and then I'll discuss all those applications whenever we are talking about the different kinds of algorithms in our further module or our further classes. But it's your responsibility to explore on your own as well, because I don't want to do the spoon feeding here. I want my students also to do the exploration part, and do let me know what things you have found out as an application of these traversal algorithms. With this, I would like to end this particular session. Happy learning to all. Bye-bye everyone. I hope that you have enjoyed this graph traversal modules pretty well, just like the way you enjoyed the previous modules. And I'll see you all in my next upcoming video.